In this video, we are going to look at transformations to absolute value functions. So recall that the base function for an absolute value function is f of x equals the absolute value of x. To get the general form, we are going to replace x with b x minus h. In the base function, the x is in the absolute value bars, so b x minus h will be in absolute value bars. We're going to multiply by a and add v. So that is the general form of the absolute value function. We are asked to graph the function f of x equals negative 2 times the absolute value of x minus 3 plus 5. So here our a value is negative 2. This means two things. First, it means that there is a vertical stretch of factor 2 because the absolute value of a is 2. But because there is a negative in front of that a value, there is a reflection in the x-axis. b is 1 because there is no number being multiplied to x minus h inside the absolute value bars. H is 3, so there's a horizontal shift 3 units to the right. And v is plus 5, so there's a vertical shift 5 units up. So step 1 is to graph the base function. So remember the key points at 0, 0, and then at 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and so on. And then the other side, negative 1, 1, negative 2, 2, negative 3, 3, negative 4, 4, negative 5, 5. So step 2 is to apply the a and b values. So again, we have a is negative 2, b is 1. So we don't actually need to do anything with b, but we do need to do the negative 2. So a affects the y value, so we're going vertically. We are stretching, and then we are reflecting in the x-axis. So it's going to open down instead of opening up. So again, I've graphed this on Desmos so we can get an accurate look at what's going on. I just drew some key points on my absolute value function, my original base absolute value function, and I'm going to transform those. So basically you're multiplying the y values by negative 2. So at the origin, the y value is 0, so 0 times negative 2 is still 0. And then here at 1, 1, the y value is 1, so multiply that by negative 2. So now the y value is negative 2, it's right here. And same with at negative 1, 1. The y value is 1, multiplied by negative 2, and it's right here, your point. The other way of looking at it is how far you are away from your x-axis. So this point is 1 unit away, so now it's 2 units away in the opposite direction because it's being reflected. And this point is 1 unit away, so now it's 2 units away. So now let's look at the point 5, 5. The y value is 5, so now the y value is going to be negative 10. So instead of being 5 units above the x-axis, we're now 10 units below the x-axis. And same with negative 5, 5. Instead of being 5 units above, we're now 5 units below. So then you would have your key points, and then just draw your function through those points. And then label f of x equals negative 2, absolute value of x, as we only applied the a value of negative 2. So now in step 3, we are going to apply the h and v values. So here h is 3, so we're going 3 units to the right. V is 5, so we're going 5 units up. So we'll take that origin, and we'll go 1, 2, 3 to the right, and then 1, 2, 3, 4, 5 up. So that's our new point. Then we'll take this point 1, negative 2, and go 1, 2, 3 to the right, and 1, 2, 3, 4, 5 up. So we have that new point. We will take that point negative 1, negative 2, move 1, 2, 3 to the right, 1, 2, 3, 4, 5. So we get this point. And then we will move this point negative 5, negative 10 to the right, 1, 2, 3, and then up 1, 2, 3, 4, 5. And then I believe I still have to move the point 5, negative 10. So move that to the right, 1, 2, 3, and then go up 1, 2, 3, 4, 5. So now that you have a few key points, you would draw your function between those points and then make sure you label it. And your label can be neater than mine. On paper, it's a bit easier. And then you can do step 4, which is to check a point. So if I was to choose when x is 8, I should get a y value of -5 when I put 8 into my function. So I will just check f of 8 equals -2, 8 minus 3. So that gives me -2 times 5. So -10 plus 5, which is -5, which is what I should have at that point.